Hello everyone, welcome back. In this video we are going to learn about Ohm's law, ohmic conductors as well as non-ohmic conductors. So let's start with Ohm's law. Ohm's law was published in 1827 by the German physicist George Ohm, and it says if the temperature and the other physical factors remains constant, then the potential difference across the conductor is directly proportional to the electric current passing through it. So I can write the potential difference V is proportional to capital I, that's the current passing through conductor. Therefore V equals Ri, where R is the proportionality constant and it is the resistance of that conductor. So I can write V equals IR. And from this it is very clear to us that the resistance of the conductor must be constant for Ohm's law to be valid. That is why in the Ohm's law it was mentioned that the temperature should be constant. Well, next let's see how we can verify Ohm's law experimentally. For this we can construct a circuit as you can see now. And we can note down 5 or 6 set of ammeter and voltmeter readings by varying the rheostat. Next, from the experimental data points, we can plot a graph of V versus I by taking I values in the x-axis and V values in the y-axis. Finally, by inspecting the graph, we can verify the Ohm's law. It should be a straight line passing through the origin, and the gradient of this curve represents the resistance. Okay, so far so good. Next, we will see what are ohmic conductors and what are non-ohmic conductors. Conductors which obey Ohm's law are called ohmic conductors. Pure metals are good ohmic conductors. The voltage versus current characteristic curve of an ohmic conductor is a straight line passing through the origin. Next, non-ohmic conductors. They do not obey Ohm's law, which is to say IV characteristic curve is not a straight line. Let us see some examples for non-ohmic conductors. First we have PN junction diode. You may have learned its characteristic curve in electronics and it is definitely not a straight line. So it's a non-ohmic conductor. Next, let's consider the filament bulb. Here is the IV curve of a filament bulb. As you can see, it has a linear variation for small voltage values. But for high voltage values, the curve deviates from straight line. This is because as the voltage is increased to larger values, the current through the filament bulb is larger. Larger the current, higher the heat dissipation. As more and more heat is produced, the resistance of the filament bulb will increase. So we obtained such a graph. Finally, thermistor. A thermistor is a type of a resistor whose resistance is strongly dependent on temperature, more so than in standard resistors. The term thermistor is combination of thermal and resistor. And clearly we can see that the IV curve is not a straight line. So it's a non-ohmic conductor. Okay, so that's it. Hope to see you again. Until then, take care.